Hello, everyone. My name is Yedomo, and I'm very glad to share with you some codes regarding how to analyze some data in our programming language. So first of all, I would like to make one introductive message. We created a new GitHub repository that we place all data that you need to reproduce this analysis. I will provide in the description of this YouTube video. And also, before running this code, you need to install R Basic and R Studio depending on which system you are using, which OS you are using. And I provide a link to show how to install R from scratch. And also we need mainly 4 packages to run our code. The package Agricolae, ggplot2, patchwork, and the last one that we need to run our code. So briefly, I will talk about the context of this data analysis. So basically, we went into different parts in South Korea. We went to the field, precisely Sesame field, Sesamum indicum, where we found a disease named wilt disease, Sesamum wilt disease, caused by Fusarium oxysporium forma speciale sesame. So once we collect those samples from these different locations, we try to inoculate, and this is basically the some symptoms of the wilting aspect of the plant. And basically, if we cut the stem, you can see brown color on the stem area. So basically, this is the wilting symptoms of Sesamum indicum. Here, we also try to grow in petri dish those spores, these fungi, and observe on microscope the microconidia and macroconidia as well. And we also use some markers to discriminate our samples, that this marker showed same band for nice band that confirm that we are really in Fusarium oxysporium clade, and 1 and 2 here are just negative control. Furthermore, we perform preliminary analysis for to place our 4 isolates into a phylogenetic tree regarding other type of Fusarium also. So now the next step of our experiment was to screen several Korean cultivar using those isolates. So in this work, in this presentation, I will just focus on one isolate that we use to screen a set of Korean cultivar, and with 5 replication. So we use one is a control with no inoculation, and one set is treatment with inoculation. And then we recorded some data, including leaf width, leaf length, chlorophyll content, plant height, and then we try to see what is difference between control and treatment from this experiment. So now I will open my RStudio. I will open my RStudio quickly, and then I will share. Okay. So now we are in RStudio, and we will try to set some basic standard before running our code. So firstly, we need to check first our working directory. Where is our working directory? So we need to write get wd to find out where we are. So here, when I run that, you can see here my working directory by default is documents. But I have created one specific folder for this work. So that folder name is r_tuto, and I have created this folder on the download folder. So it's also possible to set our own working directory using setwd function. So just place the full path to your working directory in quotation mark, and that's it. So I will run it. Okay. And then I can check again if that's worked well by running again get wd. Get wd means get working directory, and set wd means set working directory. So as you can see here, from documents, now we are in our tuto folder as working directory. This is very important as a starting point. The second point is to check if your libraries are well installed. So here we will use Agricolae, ggplot2, Patchwork, and ggsignif packages. So I will run and see. Double run. Okay. So you can see here that I have no message error after double run. Those message that I got is just a warning message regarding the version of my R. So once I set my working directory and I load correctly those libraries that I need, so I need also to import my data, the data set. So the data set that we will use here, name is YS3386. YS3386 is just the name of this isolate that we collected. So here I save this table in CSV format using comma separated option. So I give the name data_y, and to import this data, I use the function read.csv. So let's see what is in that data by using the function view. So view and the data y in parentheses, and we will check it quickly. So that's it. So in my table, I have type, column type, ID. ID means for cultivar that we use. And we have 5 replicates for each treatment, for each cultivar. So we also recorded the plant height, diameter, stem diameter, leaf length, leaf width, and chlorophyll content. So we want to see, is there any significant difference between controls and treatment? So now we want to perform, first of all, analysis of variance using the type of treatment as a factor and a variable as plant height as independent variable. So to run it, you just need to use the AOV function. The AOV function here is very nice to do analysis of variance in case of normality of data and quality of variance. So we have here the variable plant height and tilde type. Type means the type of treatment, and using our data set. It's quite very simple. And we gave a name model for this analysis of variance. So we run it. And then to get the table of our analysis of variance, we just need to provide another function of our model. And then we got this result. So basically, this result shows that we have a good p-value less than 0.001, meaning that, okay, the type of treatment has a significant effect on the plant height. So after that, we want to know if there is a difference between controls and treatments also. So to do that, we select that option, LSD test, list significant difference test based on our model and following the factor type of treatment. And we perform following also the P adjustment of Bonferroni. So when we run that, we get this a nice result. Here we got the mean value, standard deviation, and more importantly, control and treat. The difference is 1.85, and that difference is also quite significant at p-value less than 0.0001. So that means that, okay, our experiment is quite conform, it's quite good, showing that there is a plant height difference between treated plants, inoculated plants compared to controls. So how we can visualize these data? So we make a new data file that we call data height, that we call height.csv, and that data we will call it like we used to do. And that data just have 3 columns. The first one is type column, second one is mean column, and the third one is standard deviation column. So for control and infected, we provide the respective mean and standard deviation value. So then we are trying to draw a bar plot that can show the mean value, the standard deviation also, as well as the difference between the two type of treatment. So here I will explain line by line this code. So firstly, I will run this. So here I provide the name H. H is the name of height paragraph. So ggplot2 will be used. So we will use the function ggplot for our data of plant height. And we need to provide also the x axis data, as well as the y-axis data also. The filling, I mean by filling, the color of filling. So we need to fill following the treatment or control. And we are interested in to make a bar graph. So we use bar function with those following arguments. And then we also have that option to write x-y-axis title, as well as y-axis title as well. So here we provide treatment and plant height as x and y-axis respectively. So we will run this, and then nicely we can get this view here. So you can see we have those two bar graphs. but we want to add error bar. So we will use the following R code by adding plus. So geom error bar. Geom error bar is that function that we employ here to set error bar. So basically, mean minus standard deviation will be the minimum, the lower value of that error bar, and mean plus ST it will be the highest value of that error bar. And we also provide option of wide of our error bar 0.2. So let's see what we can get. So we run it, and then we can see the appearance of error bar for both bar graphs. So what is the difference? Is there any significant difference between those two values? We already saw that yes, and with 3 stars. So we'll try to show also this difference by adding this R code line. So plus here. So basically, geosignif is that function that will help you help us to do this job. So we have control and infected, and we will annotate using our 3 stars. This is just the position and the length of the tip of our 3 stars. So we run it. And then you can see that we have all information that we want to show to our reviewer or any people that would like to see our result. We have the main, we have the error bar that shows variability, and we have also the significance between the controlled and infected cultivar. So we will now customize our graph by changing the background and adding changing the background from gray to white, as well as changing also the font of our Y as well as X-axis to bold. So, and we will try also to change also the color of our bar plot. So to do that, we will try step by step. Firstly, we will try to use black and white. We will try to use this theme. This is the black and white theme that we will add to remove the gray background. So we can see here that we remove the gray background, and we can also change the font of the writing by making them bold and black. It's also possible to customize. We run, and as you can see, all font now are very bold and black to clearly see what we are doing. And then we can also add a title using GG title function. And then we make the title A. And to finish, we can also change the color of. So we use the manual scale fill manual color. This color code is freely available on internet. So there is a wide X color code that you can easily select depending on your choice on the internet. So let's try this. All right, good. So our graph looks nice. We get quite good output. So then we can try the same thing for other variables. So to do that, we will I already prepared the file for other variables. So for stem diameter, so we can see stem diameter graph also. There is a significant difference as well as leaf length value, leaf width also, and chromosome content also as well. So we got quite good result. So now we will try to plot all these graphs in one. So here I create the figure that can combine all our graphs in one graph. So here I to just illustrate, I will run directly. So we use the patchwork library. It's very important. It's very nice package that is very useful to plot multiple panels in one plot. So when I run this, okay, nicely. So I can see that I have all my graphs in one set here. So I provide the name figures. So figure equal my panel. And then I have also using ggsave function the opportunity to save my file under the name bar plot.png. And more importantly, I can set the width as well as the height of my graph, but also the DPI, the resolution of my graph. So I can increase. That is very nice for publication-ready graphs. So when I run that, automatically that figure is saved in my working directory. So to see that, I need to go to my working directory. So I will share my screen again. I will share my screen. All right. So here we are. So bar plot is automatically created. And then we can see that we have a quite good high resolution ready for publication figure that we can submit in any journal. So I will come back again and reshare. Okay, so basically that is the key message of this quick tutorial. So we have learned to do a quick analysis of variance, as well as how to make bar plots in R using ggplot2 mainly, and how to plot multiple panel graph using the package patchwork. So to finish, I will share again my screen to just mention that all these tutorials, code, and explanation are already available for free on my GitHub repository. So here we are. So it's free and you can easily check it out. And if you have any comments or any question, feel free to reach me out directly through my mail, yedomon@gbnu.ac.kr, or you can drop it here in the issue section of my GitHub. So that's it. Thank you very much for your attention, and I'm happy to share this quick tutorial with you. And if you have any question, feel free to ask me. Thank you very much.